Openstax Contemporary Mathematics, Chapter 1, Section 3, Understanding Venn Diagrams. Figure 1.6. When assembling furniture, instructions with images are easier to follow, just like how set relationships are easier to understand when depicted graphically. Credit goes to them. And it just shows a bunch of furniture and some instructions. Learning objectives. After completing this section, you should be able to 1. Utilize a universal set with two sets to interpret a Venn diagram. 2. Utilize a universal set with two sets to create a Venn diagram. And 3. Determine the complement of a set. Have you ever ordered a new dresser or bookcase that required assembly? When your package arrives, you excitedly open it and spread out the pieces. Then you check the assembly guide and verify that you have all the parts required to assemble your new dresser. Now the work begins. Luckily for you, the assembly guide includes step-by-step instructions with images that show you how to put together your product. If you are really lucky, the manufacturer may even provide a URL or QR code connecting you to an online video that demonstrates the complete assembly process. We can likely all agree that assembly instructions are much easier to follow when they include images or videos rather than just written directions. The same goes for the relationships between sets. Interpreting Venn diagrams. Venn diagrams are the graphical tools or pictures that we use to visualize and understand relationships between sets. Venn diagrams are named after the mathematician John Venn, who first popularized their use in the 1880s. When we use a Venn diagram to visualize the relationships between sets, the entire set of data under consideration is drawn as a rectangle, and subsets of this set are drawn as circles, completely contained within the rectangle. The entire set of data under consideration is known as the universal set. Consider the statement, all trees are plants. This statement expresses the relationship between the set of all plants and the set of all trees. Because every tree is a plant, the set of trees is a subset of the set of plants. To represent this relationship using a Venn diagram, the set of plants will be our universal set, and the set of trees will be the subset. Recall that this relationship is expressed symbolically as trees, proper subset, plants. To create a Venn diagram, first we draw a rectangle and label the universal set U equals plants. Then we draw a circle within the universal set and label it with the word trees. Figure 1.7. Green circle labeled trees inside of blue rectangle, set U equals plants. This section will introduce how to interpret and construct Venn diagrams. In future sections, as we expand our knowledge of relationships between sets, we will also develop our knowledge and use of Venn diagrams to explore how multiple sets can be combined to form new sets. Example 1.18. Interpreting the relationship between sets in a Venn diagram. Write the relationship between the sets in the following Venn diagram in words and symbolically. So we have figure 1.8, blue rectangle, U equals dogs, and then orange circle within the rectangle, T equals terriers. Solution. The set of terriers is a subset of the universal set of dogs. In other words, the Venn diagram depicts the relationship that all terriers are dogs. This is expressed symbolically as T proper subset U. Your turn 1.18. Write the relationship between the sets in the following Venn diagram in words and symbolically. And then we have blue rectangle, U equals cats, orange circle within the blue rectangle, L equals lions. So far, the only relationship we have been considering between two sets is the subset relationship, but sets can be related in other ways. Lions and tigers are both different types of cats, but no lions are tigers and no tigers are lions. Because the set of all lions and the set of all tigers do not have any members in common, we call these two sets disjoint sets or non-overlapping sets. Two sets A and B are disjoint sets if they do not share any elements in common. That is, if A is a member of set Cap A, then A is not a member of set Cap B. If B is a member of set Cap B, then B is not a member of set Cap A. To represent the relationship between the set of all cats and the sets of lions and tigers using a Venn diagram, we draw the universal set of cats as a rectangle and then draw a circle for the set of lions and a separate circle for the set of tigers within the rectangle, ensuring that the two circles representing the set of lions and the set of tigers do not touch or overlap in any way. So we have figure 1.9, blue rectangle, U equals cats, orange circle within blue rectangle, T equals tigers, and then green circle within blue rectangle, L equals lions, and L and T do not intersect at all. There's no points in common. Example 1.19. Describing the relationship between sets. Describe the relationship between the sets in the following Venn diagram. So we have figure 1.10. Blue rectangle, set U equals 2D figures. And then we have green circle and or is it yellow? Yeah, we'll say green. Green circle and orange circle. Green circle being T equals triangles. Orange circle being S equals squares, both within blue rectangle, but not touching each other. Solution. The set of triangles and the set of squares are disjoint subsets of the universal set of two-dimensional figures. The set of triangles does not share any elements in common with the set of squares. No triangles are squares, and no squares are triangles, but both squares and triangles are 2D figures. Your turn 1.19. Describe the relationship between the sets in the following Venn diagram. So we have blue rectangle, U equals birds, orange circle, E equals eagles, green circle, C equals canaries, both disjoint, but within blue rectangle. Creating Venn diagrams. The main purpose of a Venn diagram is to help you visualize a relationship between sets. As such, it is necessary to be able to draw Venn diagrams from a written or symbolic description of the relationship between sets. Procedure. To create a Venn diagram, 1. Draw a rectangle to represent the universal set and label it set U equals set name. 2. Draw a circle within the rectangle to represent a subset of the universal set and label it with the set name. Caution. If there are multiple disjoint subsets of the universal set, their separate circles should not touch or overlap. Example 1.20. Drawing a Venn diagram to represent the relationship between two sets. Draw a Venn diagram to represent the relationship between each of the sets. 1. All rectangles are parallelograms. 2. All women are people. Solution. 1. The set of rectangles is a subset of the set of parallelograms. First, draw a rectangle to represent the universal set and label it with set U equals parallelograms. Then draw a circle completely within the rectangle and label it with the name of the set it represents. Set R equals rectangles. So we have figure 111, blue rectangle, and we have set U equals parallelograms, and then orange circle, set R equals rectangles. In this example, both letters and names are used to represent the sets involved, but this is not necessary. You may use either letters or names alone, as long as the relationship is clearly depicted in the diagram as shown below. Figure 112, we have just blue rectangle is just parallelograms, and orange circle is just rectangles. Or, figure 113, blue rectangle is just U, and orange circle is just R. 2. The universal set is the set of people, and the set of women is a subset of the set of people. So we have figure 114, blue rectangle is people, orange circle is woman, or women. Your turn 120. 1. Draw a Venn diagram to represent the relationship between each of the sets. All natural numbers are integers. 2. A is a proper subset of U. Draw a Venn diagram to represent this relationship. Example 121. Drawing a Venn diagram to represent the relationship between three sets. All bicycles and all cars have wheels, but no bicycle is a car. Draw a Venn diagram to represent this relationship. Solution. Step 1. The set of bicycles and the set of cars are both subsets of the set of things with wheels. The universal set is the set of things with wheels, so we first draw a rectangle and label it with set U equals things with wheels. Step 2. Because the set of bicycles and the set of cars do not share any elements in common, these two sets are disjoint and must be drawn as two circles that do not touch or overlap with the universal set. So we have figure 115, blue rectangle, U equals things with wheels, green circle, bicycles, orange circle, cars. And then cars and bicycles are disjoints, but they're both completely within U. Your turn 121. Airplanes and birds can fly, but no birds are airplanes. Draw a Venn diagram to represent this relationship. The complement of a set. Recall that if set A is a proper subset of set U, the universal set, written symbolically as set A proper subset set U, then there is at least one element in set U that is not in set A. The set of all the elements in the universal set U that are not in subset A is called the complement of set A, or A prime. In set builder notation, this is written symbolically as set A prime equals bracket X element set U such that X is not an element of set A. Close. The symbol, it's like a E-ish shape, is used to represent the phrase is a member of, and the symbol E with a slash in it is used to represent the phrase is not a member of. In the Venn diagram below, the complement of set A is the region that lies outside the circle and inside the rectangle. The universal set U includes all of the elements in set A and all of the elements in the complement of set A and nothing else. So figure 116, we have blue rectangle is U, green circle is A, and A is completely within U. Consider the set of digit numbers. Let this be our universal set. So set U equals the set 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Close. Now let set A be the subset of set U, consisting of all the prime numbers in set U. So set A equals the set 2, 3, 5, 7. The complement of set A is the set A complement, which equals the set 0, 1, 4, 6, 8, 9. The following Venn diagram represents this relationship graphically. So we have blue rectangle is set U, which is the set of all, or the set of the digits, so 0 through 9. And then set A is the circle within the blue rectangle, and that's the set 2, 3, 5, 7. And then anything outside of the red circle would be a complement, and that's the set 0, 1, 4, 6, 8, 9. Example 122. Finding the complement of a set. For both of the questions below, set A is a proper subset of set U. 1. Given the universal set U equals the set Billie Eilish, Donald Glover, Bruno Mars, Adele, Ed Sheeran, and set A equals the set Donald Glover, Bruno Mars, Ed Sheeran, find the set A complement. 2. Given the universal set U equals the set D such that D is a dog, and set B equals the set B is an element of U such that B is a beagle, find the set B complement. Solution. The complement of set A is the set of all elements in the universal set U that are not in set A. So A complement is the set Billie Eilish, Adele. 2. The complement of set B is the set of all dogs that are not beagles. All members of the set B complement are in the universal set because they are dogs, but they are not in set B because they are not beagles. This relationship can be expressed in set builder notation as follows. The set B complement equals the set all dogs that are not beagles. So the set B complement equals the set D is an element of U such that D is not a beagle. Or the set B complement equals the set D is an element of U such that D is not an element of B. Or set B, sorry. Your turn 122. For both of the questions below, set A is a proper subset of set U. 1. Given the universal set U is the set red, orange, yellow, green, blue, indigo, violet, and set A equals the set yellow, red, blue, find the set A complement. 2. Given the universal set U equals the set C such that C is a cat, and set A such equals the set C is an element of U such that C is not a lion, find the set A complement. And that is it for that.